All right, here we go. We're doing one on bacterial growth or human growth or any kind of exponential growth. Here's a question stem. The population of a certain community of humans is known to increase at a rate proportional to the number of people present at time t. If the population has doubled in 5 years, how long will it take it to triple, to quadruple? Okay, so the first thing you want to notice is that rate of growth, and they're even telling you it is that the community is known to increase the rate of growth proportional to the number of people. So how would you write that mathematically then? You would just write that the rate of growth of a population, which would just be the derivative of the population with respect to time, at some point in time, would be the rate of growth at some point in time, is what? That's a proportional symbol. Proportional to the size of the community at some time t. That makes sense, right? If if there's only 2 people in this community, the rate of its growth isn't going to, how many new humans per year, is going to be pretty low. But if there's 500,000 people in a community, then the rate of how many more humans per year there's going to be within that group of people, that's going to be much higher. So that's what the proportionality means. It means it's as this goes up, this goes up. As this goes up, this goes up. It's not an equal sign. It's a little different. But there is a k which would make this equal, a constant of proportionality, which would make this into an equation. So that's what we're going to do. We're going to say dn dt equals k, the constant of proportionality, times the population of some time t. So here we go. What we need to find is the function of, see, they're asking how long till it doubles, how long till it triples, how long till it quadruples. So we need to find some function that describes the population at some time t to the number of people in it. So the function, you could say, okay, I want to know at time equals 2 years how many people are in this population. That's what we're looking for. We're looking for a function of this. So how do we solve that? We got to solve, it's a differential equation that we got to solve. We got to solve this for the function, population function as a function of t. This, really. Okay? So how do you do that? Well, what kind of differential equation is that? Well, first of all, is it separable? Yeah, it is separable. So I'm going to do it a couple different ways. This is kind of going to be a long video, but this is separable. If you just cross multiply these here, you get dn kn equals dt. You see that? Multiply it like that. Kn is a function of t. Okay? And then you can just take the k out right like this. Integrate dn 1 over n. Do you see that? See how I got that from there? Equals the integral dt. So this, in my opinion, is the easiest way to solve this differential equation. See how quickly I did that? This is just basic algebra right here. I multiplied this side by dt, the dt's crossed out, the dt popped up over there. See? This side I divided by kn, and I divided this side by kn, I got the kn right here. So it's, you pull the k out of the integral, 1 over k, okay? So let's solve that. And let's bring it up here, okay? So I'm going to bring this up here. So that's going to be log n over k equals t. This is a 1 in here. What's the integral of a 1? It's just the variable you're integrating plus c, because you got your constant of integration. Okay? Now what? Now you just multiply this through. So you got log n equals kt plus kc. Now what? Expose this to the base e. These are inverse functions, they go away. You got n equals e to the kt times e to the kc. What's e to the kc? E to the kc is C, just some C. C1 you can call it, right? So what's this? There's the function. You got population as a function of time is equal to some constant C times e raised to the constant of proportionality times t. That's your answer. Okay? We're going to do this one other way just for the sake of completeness. We're going to do this one other way. Okay? The other way we're going to do this is we got this here, right? Equals k and t. We got this. What else can we do? Well, subtract this from both sides. We get dn dt minus kn equals 0. Right? What's this? Is this a first order linear differential, ordinary differential equation? It is. You got n prime minus kn equals 0. This is a function of x. 0. 0 is a function of x. Why not? Okay. So, what's the integrating factor here? The integrating factor is going to be this. E. So, it's going to be e raised to the integral of the negative k dt. Right? What is that? That's e to the negative kt. That's your integrating factor. Now, multiply this to both sides. So you have e to the negative kt d and dt minus e to the negative kt e to the negative kt dn dt minus k to the n equals e to the negative kt times 0. This is just 0. This, could you rewrite this as the derivative of e to the kt n over dt? Could you? Yeah. If you were to do the product rule, you would get this. If you were to do the product rule on this, you would get this. I'm not going to do it though. If you were to do the product rule on this, so it would be, you know, you would get this. Yeah. So we should come up with the same thing. We should come up with the same answer we got right here, which is this. N is a function of t equals c e kt. So this equals 0. Now what? You can say it, you can go like this. dt, dt. These are inverse functions. They go out. E to the negative ktn equals, this is just c. Then you divide out e to the negative kt on both sides. And you have n as a function of time equals c divided by e to the negative kt. Negative kt goes up. And you have n as a function of t equals c e to the kt. And that's the same as this. This is the same as that. So I did it 2 different ways. So, you know. Alright, so now that we have the function, I'll just leave this up. Now that we have the function, what's the function? The function is n as a function of time equals c e to the kt. Well, the first thing you could do is say, what is it at t equals 0? At t equals 0, right? Well, at t equals 0, n as a function of t equals 0 equals c, what's this? E to the k times 0. This goes away to 0. E to the 0 is 1. And you have NO equals C. So now you have C. C equals the population at time equals 0, which we call N naught. So you have to rewrite this now. So we have n to the t equals c, which is really n naught, times e to the k t. Right? Now we want to try to find k. So we're told in the question stem here, the population doubles in 5 years. So write that in English. So in 5 years, n t will be twice n naught, where n naught is the original population. So 2 times no equals nt. So then we could write 2no equals, we're replacing 2no for nt equals no times e to the, and this is at 5 years, k times 5, right? This is at 5 years. So at t equals 5, we know that the population, which is n at time t, is equal to 2 times the original population size at t equals 0. That's what we have. These NO's cancel out with each other. So we have, let's bring this up here. Sorry, this is kind of sloppy. So we have 2 equals e to the k 5. Now let's take log 2 equals log e k5, right? That's just going to go away. So that's log 2 equals k5. Log 2 is like 0.693 over 5 equals k. See what I did there? Kind of a little sloppy. Let's calculate that. 0.693 divided by 5 equals, where's the stupid? Okay, equals 0.139. Alright, so now we have everything to put the formula back together. So we have the population at time t equals NO, that's what C is now, times E to the, what's K, 0.139 T. So now all you need to know is T. And just put this in a function of NO. So now we go to the question that's an unknown. How long will it take it to triple? Let's just do the triple instead of quadruple. Well, at nt equals 3 times no, it will have tripled. Do you see that? So we have 3no equals no e to the 0.139 and t. We're trying to find this time. How long will it take to triple? That's what we're trying to find. These NO's cross out with each other, right? So we have 3 equals E 0.139 T. Log 3 equals 0.139 T. Now, so we have log 3 over 0.139 equals T. So you just calculate that. So it'll be log 3 divided by 0.139. Log 3 divided by 0.139 equals 7.9. So how long will it take? For the population to triple? 7.9 years. And then quadruple is just you do the same thing.